Hello, my name is John McIntyre. I'm excited to share today how you can use Azure Data Services to create data-led insights and actions for your business applications, delivered by Dynamics 365 or built from the ground up with the Power Platform and Microsoft Dataverse. With the increasing volume of data generated through every facet of business, ranging from customer engagement, products, operations, and employee experience, it is more important than ever to ensure everyone in an organization can participate in creating new business value through data. This includes professional developers, as well as domain experts and citizen developers who are closest to the business problems. Azure and the Power Platform offer a rich set of tools and capability for professional developers, as well as powerful and easy-to-use tools for low-code and no-code development. We believe that the combination of Azure and the Power Platform is incredibly unique. As data is shifting to the center of application innovation and providing rich application experiences, Azure provides a complete set of data and AI services for application developers. This includes database services, analytics platforms, including Azure Synapse, AI services, and data governance capabilities with Azure Purview. Dataverse is a managed service for your business data that supports any app and any developer. Whether you're a citizen developer or someone with a little more seasoned experience, or even a professional developer, Dataverse removes the complexity of managing your data tier so you can focus on building your app. Breaking down data silos is necessary to empower developers to drive innovation and insights. Last year, we announced Azure Synapse Link for Azure databases to break down the barrier between operational data and analytics systems. When these data silos are removed, it enables new insights, new actions, and new experiences. Another barrier that impedes time to insight is the silo that exists between business application data and analytic systems. As developers use platforms such as Power Apps, Power Automate, and Dynamics 365 to create and deliver business applications for their organization, the data that comes from these applications is stored in Dataverse. As you can imagine, this provides amazing potential for new insights. However, when organizations want to discover deep insights, derive new actions, or create predictive experiences through the combination of Dataverse data and other data sources, it requires stitching services together or constantly copying data back and forth. This results in a lot of ongoing maintenance and work for data teams. Today, we're pleased to announce Azure Synapse Link for Dataverse. You can now automatically ensure that data flowing into your business apps is immediately available for your analytics solutions. This enables you to perform analytics tasks while also managing data in your business apps. All this without creating complex extraction pipelines or processes. In just a few clicks, developers working in Power Apps or Dynamics 365 can bring the entire Dataverse environment to Azure Synapse to explore, prepare, manage, and serve data for immediate business intelligence and machine learning needs. You can also combine this data with your other enterprise data assets. I would like to welcome Nellie Gustafson to show Azure Synapse Link for Dataverse in action. Nellie?
Thank you, John, and hello, everyone. Now, let's walk through a scenario of how you can leverage some of the exciting capabilities that John just mentioned. Let's say that I'm a data engineer at a large retail company, and we currently leverage the rich capability of Dynamics 365 to provide an end-to-end view of our customers. As with all retailers, however, we are continuously looking to enhance the customer experience. And it is critical that I can empower the business users throughout my organization with relevant insights based on what is happening right now across various data sources. Now, let me show you how we can leverage Azure Synapse Link for Dataverse to make this happen. We're starting off in the Power Apps Maker portal, and we're going to launch the new Link to Data Lake wizard. Here, we're going to select Connect to your Azure Synapse Analytics workspace, and we're going to add a few subscription and resource group details. And as I fill in these resource group and subscription details, it's actually going to pull through my workspace name and default storage accounts. The next step is to select which tables that we want to publish to Azure Synapse. I'm going to select the account table and the opportunity table. Now we're starting the linking process. And as soon as the linking is done, we just need to select the linked data lake and use the shortcut right here to launch our Azure Synapse Analytics workspace to start exploring the data. This way, with just a few clicks, developers working in Dynamics 365 and Power Apps can bring their entire Dataverse environment to Synapse for analytics and enrichment. This really boosts developer productivity. Let's navigate to the Data Hub. And here's an example of how we can quickly get started to query the data from Dataverse. Here we see the two different tables that we just published. And using T-SQL, we can immediately get started to explore our data right over the lake. And as you can see here in the Data Hub in Synapse Studio, I can pretty much access all my data sources managed by Synapse, including the data lake, data warehouse, and other external sources. In this scenario, Azure Cosmos DB serves as a database for our customer mobile app, and it contains a wealth of information on real-time customer reviews of our products. And I've already enabled the Synapse link for Cosmos DB, as you can see here, so it's now available here in my workspace as well. Now let's get started and query across these two business applications. For that, we're going to navigate to one of the notebooks that I have in my workspace. And using Apache Spark, we can now join the two datasets easily on the account number key, as you see here, and then write the data back to the data lake for some AI-infused data enrichment. To do this, we're going to leverage text analytics AI capabilities of Azure Cognitive Services to perform sentiment analysis on the product reviews right here, right from our Synapse workspace. So let's go to our workspace data and right-click on the account sentiments, which is a table that we just saved to the data lake, where we want to add the sentiments. Now, let's select Enrich with Existing Model. Azure Synapse actually has a lot of built-in integrated machine learning experiences, both with Azure Machine Learning and with Azure Cognitive Services. And in this case, we're going to leverage text analytics and sentiment analysis to get the sentiments of those product reviews. And as you can see here, right here in Synapse, I can enrich my data using Azure Cognitive Services. I just need to provide a few details before I can proceed. And here I simply select the product review content column, which is a text column that we want to perform the sentiment. And I provide the language. After that, I can click Open Notebook. And this experience is actually going to generate code for me so that I don't even have to write a single line of code to get the sentiments from the cognitive services. I can now run this generated notebook and get the sentiments added back to my dataset by calling cognitive services. And by using the built-in notebook visualizations, I don't even have to do any extra work to start exploring the data. Right here, I can get a good starting point for exploring the results and visualizing the data in various ways. And since this is all in a notebook, I can also add additional code in order to explore this further. Here, we're adding a cell to summarize the sentiment scores and group them by salesperson to see which sellers have the highest customer satisfaction for given products. And again, we can leverage the built-in visualizations to get a better understanding of our data. And the next step would be to save this data back to the lake and serve it for analytics reporting. And in this way, business users and various data professionals can now collaborate over the same data. Now, to summarize it all, we just saw how Synapse Link enables real-time analytics on top of data coming from business applications, and how Synapse, together with Azure AI, improves the productivity of data professionals by making it super easy to enrich data and gain insights from the data. I can't wait to see what you all build with these new capabilities. Thank you, and back to you, John.
Thanks, Nelly. We have also made significant performance advances in Apache Spark for Synapse since we launched the product. With Spark 3, this includes new performance capabilities such as adaptive query execution, dynamic partition pruning, and optimized pandas UDFs. We have also done additional performance tuning on Spark 3.0, and with the Synapse version, we are already seeing processing speeds 2 times faster than the open source version. We expect this to get only better with all of the work that we're doing around hardware acceleration. Delta Lake is one of the most popular and widely used Spark features. Moving to Spark 3 allows you to use the latest capabilities and new APIs, such as the SQL API for merge. While 60 to 80% of code submitted to Spark is PySpark, SQL is still the language of choice for many of these operations and for many organizations. Moving to ANSI-compliant SQL makes it easier to use existing skills developed for relational databases. By adding support for Spark 3, it is now possible for us to also leverage GPU capabilities in Spark and enable the recently announced NVIDIA Tesla T4 GPUs. The built-in support for NVIDIA Rapids acceleration provides over 3 times improvement in standard analytical benchmarks without any code changes. Combined with Microsoft's Hummingbird for Spark, which rewrites ML models to allow them to be accelerated by GPUs, this offers up to 3 orders of magnitude performance improvement. Let's have Misha Desai demonstrate this for us. Misha?
Thanks, John, and hello, everyone. As John mentioned, Apache Spark 3 is now available in preview within Azure Synapse Analytics. This enables many new improvements and scenarios around performance optimizations, SQL compatibility, as well as support for richer APIs via improvements to the existing pandas UDFs, as well as new capabilities around GPU scheduling. The new Azure Synapse Apache Spark 3 runtime also includes support for Delta Lake 0.8. In this demo, we'll see how we can use the new Delta Lake capabilities to take our staging table and merge it with our existing Delta table and ultimately serve the data with Azure Synapse serverless SQL pools. Our dataset contains product reviews and calculated sentiment across various users and products. Now with this release, users have access to a richer set of DML and DDL commands. This greatly simplifies the workflow for many common big data operations. Now, over time, organizations might also find that their schemas are evolving. Now, with Delta Lake 0.8, merge operations now support schema evolution of nested columns. Now, in our example, we previously had the review content and sentiment score as part of our original schema. Over time, our schemas now evolved to also include information about the review length. In a single atomic operation, merge performs the following. First, it issues an update for the rows where the user, review, item, and account numbers match, and then it inserts a new row for the rows that don't match. When we look at the history of our merge commands, we can see that this updated a total of 10 rows and then inserted another 30. Last, another new Delta Lake 0.8 feature is the ability to provide check constraints. Now this allows you to check existing data and also enforce future data modifications. Now once we finalized our Delta table, we can then query our Delta table directly using serverless SQL. And so here, when we switch over, we can see that our query is applied directly on top of the Delta data, and then directly obtains the minimum and maximum review lengths for each of our different sentiment scores. Next, let's take a look at how users can accelerate their Spark operations with GPUs in Azure Synapse Analytics. This capability is currently in private preview. Now in this demo, we'll see how Spark 3 enables us to orchestrate end-to-end pipelines with GPUs, covering everything from data manipulation to model training and model scoring as well. Now first, as a data engineer, I may have extensive queries and ETL operations that I need to run. In this scenario, I want to identify the total sales and the number of sales across various sales channels. Now, when I take this query and I execute it on a traditional CPU Spark cluster, I see that this takes just a little over 6 minutes to run. Now, using the native support for Spark 3 and the NVIDIA Rapids Accelerator, I can accelerate these ETL pipelines dramatically. The same query that took 6 minutes to run now just takes a little over 3 minutes to run when using a Spark cluster that's been accelerated with GPUs. And so, as you can see, we get a 2x speed up in processing time when we use Spark 3 and the NVIDIA Rapids Accelerator. This requires no additional API changes from the user, and the plugin is able to accomplish this by taking our traditional SQL operations and then accelerating them with its GPU accelerated versions. Next, let's take a look at how GPUs can also be used to accelerate some of our model scoring workloads. Here, we'll use a library called Project Hummingbird. And so Hummingbird is a library that allows us to take trained and traditional machine learning models and convert them over to a series of tensor computations. Now, in this demo, we have data containing order, sales, and inventory information across various retail locations. We want to be able to take this information and predict the total estimated revenue for the next year for this given retail organization. Now, to do this, we're going to go ahead and load a model that's already been trained directly from our Azure Machine Learning Model Registry. We will first run batch scoring with the scikit-learn model on a CPU-enabled Spark cluster. And we're going to compare this against the same model that's been converted into a PyTorch format using the Hummingbird library, and then accelerate it on a GPU-enabled cluster. And based on the results, we see that with GPUs, the total prediction time here is just a little over 55 seconds, and this represents almost a 4x speed up in model scoring time. And so as you can see, Hummingbird and our GPU-accelerated Spark clusters enable organizations to reuse their traditional ML models while still benefiting from the optimizations in neural network frameworks and native hardware acceleration options available in Synapse. In summary, you can see how Spark 3 enables multiple new scenarios and capabilities, including enhancements to Delta Lake, various performance optimizations, richer APIs, and GPU access. Thanks for listening in.
Thank you, Misha. You can get going with Spark and Azure Synapse, as well as serverless data lake exploration with SQL through our free offers. Go to aka.ms/synapse-now to learn more. As part of the Power Platform, Power BI offers a low-code approach to self-service BI. I'm happy to announce a powerful new capability, Power BI Streaming Data Flows. This will be available later this year. Our vision with streaming data flows is to remove the complexity and distinction between batch data processing and streaming data. Streaming data flows allows every business analyst to work with streaming data with beautiful drag and drop, no code experiences. You'll be able to mix and match your streaming data with your existing data sets. Working with streaming data is no longer just for data engineering experts. Streaming data flows will allow Power BI authors to ingest, mash up, model, and build reports based on streaming and real-time data directly in the Power BI service. This will be done through a friendly UI with diagram view for easy data mashup. The final artifact produced will be a data flow, which can be consumed in real time, creating highly interactive near real-time reporting. I've asked Miguel Martinez to come and demonstrate this for us. Miguel?
Thanks, John. I'm super excited to be here to give everyone an early look into streaming data flows in Power BI. Analyzing real-time data is becoming increasingly important for all organizations, but current tooling requires the support from developers and data engineers, which we all know it's an important and very scarce resource. We truly believe that the distinctions between batch, real-time, and streaming data will disappear, and that streaming data flows will give the opportunity to analyze streaming data to millions of business users and frontline workers. Let's take a look. Okay, let's start in a Power BI workspace creating a new streaming data flow. You can see that this is the same experience for every other Power BI artifact. So we're going to name it and we're going to click create. So after doing this, we'll land in the authoring experience. I'm going to add an input, which in this case is an event hub, and then I'm going to paste the connection string for that event hub and click save. It's that easy. I can add the fields manually if I want, or I can ask Power BI to auto-detect all of the fields coming in, and then I get presented with a live preview, seeing all the messages coming right away. To output in Power BI, what we have is an output table. It's as simple as that. We can just name it, and then all of that data is going to be dropped in Power BI. But also authors have all of these different transformations available. In this case, let's set a group by, and you're going to see that it's very specific to streaming because besides choosing the specific group by aggregation type that I want, which in this case is count, I can also choose the windowing type, very streaming specific calculation. In this case, I'm going to choose 10 seconds and add another output table to get all of that data into Power BI to access later if I want to build a report. After I'm done with all of these, I click save. I can see that everything is okay. And then I can actually go back to the workspace and start the streaming data flow to get data from the input, which is the event hub, into Power BI. And once the streaming data flow is running, we can go to Power BI Desktop the same way we would do before, select the Power BI Data Flows connector, and look for the workspace where we're keeping all of these streaming data flows and select the entities that we want to bring in, either one or more like I had here running before we started this demo. Once I click load, you can see that all of those fields are going to be available for me in desktop to start creating a report. After we publish the report into the Power BI service and we connect that workspace into Synapse, you can see here that within Synapse, I can go and select that report that we just created and start authoring directly in Synapse. So in this particular case, let's go with a very simple example. Let me add a line chart, and then I'm going to use the live fair analytics table. And like a good friend in the Power BI team says, I'm going to do some clicky, draggy, droppy, and bring time and fair to get revenue over time. Now, you're going to say, this is not moving, this is not real time. Using automatic page refresh, which refreshes as often as 1 second, I can turn that on and see the real-time visuals come to life in Power BI. As you can imagine, we can do this as many times as we want and also with any visual available in Power BI. To give an example of the possibilities here, let me make a little bit more space and show you a final report that I created beforehand. In this one in particular, you can see that we have a map updating with real-time locations, the same line chart that we created, and also a table that is using measures and other capabilities available in Power BI. To wrap it up, let me summarize what we just saw. Streaming data flows in Power BI provides a seamless, self-service, low-code, no-code experience that data analysts can use to create streaming data pipelines using their own business logic. Later, they can create the same interactive reports they already know and love with visuals that update in real time, all while keeping data secured and governed with a solution built on top of Azure's powerful streaming services. Thank you so much, and back to you, John.
Thanks, Miguel. As data becomes fundamental for maximizing business value, managing and governing that data across a growing on-premises, multi-cloud, and SaaS environment is essential. As you can see, our newly announced unified governance service, Azure Purview, has already had incredible success. What's even more exciting is that Azure Purview exposes the open source Apache Atlas framework for interoperability. With this, you can programmatically interact and build applications using Azure Purview's Atlas APIs. Azure Purview sets the foundation for effective data governance by helping with automated metadata discovery, AI-powered classifiers, and end-to-end lineage. With the help of built-in connectors and Apache Atlas APIs, you can unify all of your data on-premises, across clouds, or in SaaS apps. On Azure, MySQL and PostgreSQL are commonly used databases for developing applications. I'm happy to announce the availability of built-in connectors for these popular open source databases. You can now automatically scan and classify data residing in Azure DB for MySQL and PostgreSQL. Whether you're building a web application with smaller data sets and high-speed queries with MySQL, or you're building an app with rich data processing needs with PostgreSQL. They both can be scanned and classified with Azure Purview. We are also now able to help you add a richer semantic layer of metadata with even more system classifiers and built-in support for custom classifiers. We have doubled the number of classifiers available to over 200, helping you annotate data that may be sensitive or require specific data handling policies. Let's see this in action. I'd like to invite Vishal Anil to show us some of these new capabilities. Vishal?
Thank you, John. Now let me show you how you can register, scan, and discover all of your Azure database for MySQL and PostgreSQL assets from within Purview. You'll first navigate to your Purview account and click on Register Sources. You can view all of your sources that are grouped by collections here. You will then click on Register, and we have listened to your feedback and now support more than 20 source types, ranging from Oracle to SAP ECC to Azure Database for MySQL. Let's select Azure Database for MySQL and give it a suitable name. Select the server and the collection to which it should be associated to register the source. Now that we've registered the source, we can set up a scan by clicking on the quick action icon here. We will again give it a suitable name, select the database that we want to scan, and the credential. So all credentials in Purview are stored securely via Azure Key Vault. Let's test our connection. Click Continue, and now we can scope our scan to specific tables that we want to scan or the entire database. So let's select the entire database and then select our scan rule set, which represents a bunch of configuration options for the scan. Let's view details for this rule set and see the different classification rules that are selected. Looks like there are about 207, and as John mentioned, we now support 206 system classification rules that helps you identify the most commonly found PII out there, whether it's email ID, IP address, etc. So let me select this scan rule set and then set up my scan schedule. So I can run my scan every week on Sundays at 12 a.m. Review my scan and run it. Now I've already run this scan before, and we can see how the assets show up. The process for Azure Database for PostgreSQL is very similar to what we saw for MySQL here. So let me go try to browse for the MySQL assets. And now I can see that there's this server and this database. Let me click into one of these tables and I can view all of the details, including the schema classifications, the hierarchy, and I can additionally annotate it with glossary terms and descriptions as well. Now, if I view the schema, it looks like there are 4 columns and we automatically classified 2 of them to contain person's name. You can also define custom classification rules to be able to identify this actor ID column as well. We support lineage from ADF and data share, and looks like there's a copy activity that's moving content from this MySQL table to the ADLS Gen 2 account here. You can also view your related assets, the different tables that are related to this particular table. Now the next thing you can do is associate your Purview account to your Synapse account and be able to discover the same assets from within Synapse. So I've already done that. So let me try to search for the same table here, which is actor. And I'll be returned a bunch of results, and I can filter it down to the PostgreSQL and MySQL results. And when I click on this particular table, you will see that it's the same table that I can discover from within Synapse, and I can use it for my analytics and warehousing workloads, and finally visualize the data in Power BI, thereby adding end-to-end value for all of our customers. Back to you, John.
Thank you, Vishal. As we look at all these exciting announcements, it's clear. Azure Synapse, the Power Platform, and Azure Purview offer limitless possibilities for getting the most value out of your business data. We are truly excited to see what you build next. Thank you.